We're back into our own book, book 2, Similar Figures, or as I like to say, I call them mini-me. Get it? Because they're exactly the same, only a different size. We're on page 159. Surely you've already gone over this welcome work. I put this slide in here because I know you've already copied it down from the board that we went through it. So I'm going to move on to the next slide and get right into it. Similar figures. I'm on page 159. Hopefully you brought your book today. Page 159. What we're going to do, we're going to identify whether or not polygons are similar. We're also going to find a common ratio for corresponding side lengths of similar polygons. All that means is that they are similar. That's kind of the definition of similar. So both of these just means they're similar figures. And similar's like, yeah, they're totally equal. They're only just a different size. I put a little pentagon here. On your page, you're still on the same page, but I'm moving on. All right, you got two photos right here of the pentagon. What's different and what's the same about these pictures? Maybe press pause and write down a few things that you think are the same and a few things you think are different about these, and come back in like 30 seconds. Great. Hopefully you press pause and you kind of looked at these and could kind of tell they look exactly the same, only they're a little bit different. This one's bigger and this one's smaller. So how are these photos alike? Well, they're the same building. They have the same angles. So all these angles are the same. Everything's the same. Only one of them's a little bit bigger than the other one. And how are they different? Well, one of them's smaller, right? Same picture. Everything's the same. One's bigger, one's smaller. That's what similar figures means. I'm on page 160 now. At the top of the page, it tells you to use a protractor and a ruler to measure the lines and line segments and angles in both photos. I'm going to go ahead and do that for you. So after I reveal the two columns, copy those down in your book. All I'm doing is saving you the time of measuring the angles and measuring the sides. So I'm going to reveal those. Press pause now. Are you back? Great. So I went around with my own handy-dandy ruler, measured those. AB, which would be this side from here, A to B is 40, B to C, 29, C to D, 37, D to E, 47, and E to A, 23. And then I measured the angles. So when I'm talking about angles, I'm talking about this, right? The measure of angle A is 131. The measure of angle B, 144. The measure of angle C is 60. The measure of angle D is 138. And the measure of angle E is 67. Hopefully you got all those filled in. If you haven't filled them in, fill them in right now and then come back. I'm on the bottom of page 160 again. And you basically have to do the same thing for this second figure. So it tells you side F to G. F to G is 36. G to 8 is 27. H to I, 35, I to J, 43, J to F is 21, and the angle measurements are there. Listed 131, 144. I'm going to flip back. You can stay on this page because you're on the same page as your book, page 160. But you notice how the angle measurements for this figure and the angle measurements for this figure are the same. That means they are similar. Flip over to the next page. You should be on page 161. Sorry, I didn't write it on there. Page 161. So similar figures are figures in which the lengths of corresponding sides are in proportion. Proportion means what? Fraction, right? Proportion means fraction. And the corresponding angles are congruent. Corresponding parts of similar figures and sides of angles that are the same relative positions of the figures. That sounds confusing, doesn't it? Congruent just means it's equal. Congruent means equal. You're going to see this little symbol right here, and that means it's similar to. So if I said I have some shape, we'll call it triangle MC, and I said it's similar to triangle ED, you know that those have the angles are equal and the sides are corresponding. This little symbol right here, you see, it's kind of like a wavy equal sign, means similar. And to sum all that up, here's two. These two are congruent, right? Congruent means they're exactly the same. They're equal. And these two are similar. So in other words, if this side was 1 and this side was 1, let's say this was 2 and this was 2. And if this is 2, this would have to be, try to guess, 4, right? And if this was 3, this would have to be 6. So this side, right here, from here to here, is similar to this side right here. They're in direct proportion, right? I could write it as a fraction. And if you notice, they all come out the same. They're all going to equal the same proportion. All right, flip over to page 162. Let's do a few samples. I think that'll help you get it the easiest. It says rectangle ABCD, this rectangle right here, is 6 feet by 8 feet. Rectangle QRST is 10 feet by 12 feet. Go ahead, after when I say go, click pause and answer these 6 questions in your book. It'll only take a couple seconds, but really quick. Click pause. No, click pause. Click pause now. Welcome back. All right, name the corresponding angles. Well, angle A, this angle right here, corresponds with what? Angle Q, right? Because this is between the 6 and the 8. That's between the 10 and the 12. So we know that angle T, I'll put a little mark in there, corresponds to this angle. Angle C, right here, I'll put 2 marks on it, corresponds to angle S. So when I say that these are similar triangle or rectangles, you know that the equal angles are corresponding. They're the same. Did you do the rest of it? I hope you did. The corresponding angles congruent? Yes, they're so all the angles are equal because they're all 90 in this one. Let's name the corresponding sides. Well, we know that AB, let me get my highlighter out. AB right here corresponds to QR right here. I'll get a different color. AD corresponds with QT. CD corresponds with TS. And of course, BC corresponds with RS. All of those are corresponding. Write the ratios corresponding with. So in other words, they took AB, which is 6, over QR, which is 10, and made a fraction out of it. Okay, so if AB equals 610, then I could do AD, right? AD is 8 feet, and Q10 is 12 feet. Are those proportional? Meaning, are they the same fraction, equal fractions? No. 6/10 equals 3/5. 8/12 equals 2/3. Those would have to be equal if they're corresponding. So this one is not. Hopefully that didn't throw you off. You know our book loves to do that. So is rectangle ABCD similar to rectangle QRST? No. Although the angles are all the same, the sides are not proportional. They have to be proportional, equal. So if I reduce the fraction of this side over this side, it should be the same reduction as the fraction of this side over this side. And we know in rectangles, opposite sides are equal, right? Of course we do. Well, let's look at page 163. Just kind of briefly, they try and throw you off in our book all the time. It says, are the ratios of these corresponding sides to the right triangle shown to be equal? And explain. Are they or are they not? Yeah, I think they are. Let's prove it, though. I put this orientation slide in here. You might want to put a star by it in your book there. Orientation just means they flipped it around, and I put turn, turn, turn. So the orientation of figure is the way it's just positioned. I could flip that triangle right back over, right? And we know that this part, the slope part, is that. And we know that this part right here, if I turned this around, would be that. And this part right here would be that. So let's see if these are equal. Okay, I'll put this one side, 5, over this one side, 10. And I'll put this side right here. Does that equal this side, which is 3, over this one, which is 6? Well, 3/6 we know reduces to what? You're right, 1/2. Does 5/10 reduce to 1/2? Yeah, it sure does. So yes, these are similar triangles. Let's look at page 164. I'll try and go through this real quick. We're going to take the properties we just know. We're going to apply those properties of what we know about similar figures to find the missing lengths, the part we don't know. And we're, of course, going to solve those problems using similar figures. Let's do this one right here. Number one, it says ABC is similar, that's what that squiggly thing means, to DEF. So we know that. So we know that angle A equals angle D. Angle B equals angle E. Angle C equals angle F. And here's how we can set up proportions. I'm going to find a proportion from A to B and set it up proportional to D to E. So AB equals 3 and DE equals 12. Let's reduce that fraction. What do you get? 1/4. You're right. You get 1/4. So if I know that, I can take BC, this line right here, which we know is what? 5. And we don't know what this line is, EF. Okay, that's just an X. And as you know, because we've done it a million times, to figure this out, we could cross multiply and divide. 1 times X is X. Remember that? Cross multiply, solve for your variable. 4 times 5 is 20. And we don't even have to reduce that. It says X equals 20. So this side has to equal 20. Let's see if that's right. Well, 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. That's all that means. That's how easy it is. Let's flip over to page 166. All right, I don't know why the page numbers aren't on there. I made a mini mistake. Get it? Mini-me. Page 166. What I'd like for you to do is to go ahead and work these two problems out. Okay, and then I'll come back and give you the answers, and then we're going to work these two problems out. They're kind of the same. It should go quickly. Click pause now. Welcome back. I'm going to just go over this. So this said, what is the common ratio of side A to D, this side right here, A to D, to side VZ or WZ? So 15 over 6, and when they just reduce the fraction, that's all you got to do. I bet you got that right. Find the length of segment WX. So they want to know what this side is from here to here. Well, we know what this side is, and we know that this is proportional, right? Of course we do. So it's 10, and all they did to figure that out was set up a fraction, right? They took 15 over 6, or you could take 5 over 2. Smaller the number, the easier to figure it out, right? I got that from number 6. And make the proportion up top. So we know that if this is 5, this is 25. You got to keep the same proportion over X. Cross multiply 5X equals 50, right? When we cross multiply that. Solve for X. You get X equals 10, right? 5X equals 50. Made a mistake there. So X equals 10. Go ahead and click pause, and I'll do 8, 9. Welcome back. Number 8 is 30. How'd they get 30? How long is segment LN? So they're asking for this to here. We'll set up a proportion. We know that we got 15 over 10 over here. We know that those sides are similar, right? 15 over 10. And then just put X over 20. Solve for X. Solve for X, you get 30. How long is segment UV? So from here to here. Well, let's set up the same proportion. We could put 15 over 10. We know that one. And then we set that up so that it's 27 over X. Solve for X. X equals 18. X equals 18. I hope that helped, guys. If you need to rewatch it and work through some of the problems, I would do that. Otherwise, there's a short quiz and then IXL. Have a great day.